Hey, welcome back to Stewart Science. I got a real quick video today for you about how we classify matter. Specifically, I'm looking at four terms: mixtures, pure substances, homogeneous, and heterogeneous. So the difference between a mixture and a pure substance is that a pure substance has 100% one chemical formula. So when you split them up, you have matter. It can either be a pure substance or a mixture. A pure substance has 100% one chemical formula. You can write the formula for it. A mixture has more than one chemical formula in it. So the dividing line here that I always think about is 100% grape juice. If you went to a store, you got a juice box, it's 100% grape juice. Is that a mixture or is that a pure substance? And the answer is it's a mixture. It might be 100%, but grape juice is not on the periodic table. You can't write a formula for it because what makes it grape juice is water and sugars and grape flavorings and purple dye and whatever else they put in it. So it's still a mixture, even though it's 100%. Unless you can write a chemical formula for it, it's not a pure substance. Now, if you can write a chemical formula for it, that's broken down into either a compound or an element. Now, the breakdown here is that a compound has more than one element involved, whereas an element is just one element. Now, it could be, O2, gas. That's still just an element. Even though it's two atoms bonded together, it's still an element because it's one element that's involved, as opposed to H2O, which would be two elements, hydrogen and oxygen. So compound is two or more elements involved. An element is just one element. Now, if it's not a pure substance, if you can't write a chemical formula for it, if there's more than one chemical involved, it's a mixture. And those mixtures can either be, big words here, homogeneous or heterogeneous. Homogeneous means it's evenly mixed. And heterogeneous means not evenly mixed. When I think of a heterogeneous mixture, I think of oil and water. You can shake it up for a second, but after a while it'll still separate out. It doesn't evenly mix. Whereas a homogeneous mixture would just be sugar in water. Because if you put sugar in water, you stir it up, you dissolve, you wouldn't know just by looking at it there's two things there. So if it's evenly mixed, if it's all evenly mixed, that's a homogeneous mixture. If it's not evenly mixed, if you can still see the differences, it's a heterogeneous mixture. And that's even what the words homo and hetero mean. The prefix hetero means different. The prefix homo means same. So if it all looks the same, it's homogeneous. If it looks like there's different things involved in it, it's heterogeneous. I do want to call your attention to one thing though. A compound and a homogeneous mixture are often confused because they both involve different elements and they both appear to be evenly mixed. Now, what makes the difference between a compound and a homogeneous mixture is if those atoms are chemically bonded together or if they're just in the same space. So H2O, you have to use a chemical reaction to get the hydrogen and the oxygen apart. That's a compound. Whereas sugar and water, if you just let it sit around and the water evaporates, you'll see the sugar still remains at the bottom. So a homogeneous mixture and a compound, that's where people really get those two confused a lot. It has to be two chemicals involved in the same space but not chemically bonded for it to be a homogeneous mixture. So if you can't write a chemical formula for it, it's this one. If you can write a chemical formula for it, it's a compound. As always, this is Mr. Stewart. Keep learning, no matter what.